10 blocks and one of the blocks got compromised, things got changed there. So how do you know, or fix that error or that node, or what you do with that node? So there are some of these protocols which are again being developed. So we'll not go again much in detail because it'll be covered anyways in the later sections. Now let's look at the working of a blockchain. Now let's say I have A and B. So there are two users, A and B. Now A wants to send some content to B. So I have a content server. The first block of transaction contains content hash, ownership, modification history. Now the block is broadcasted publicly to everyone in the network for verification. Now the nodes in the network approve the validity of the transaction, and then the history of transaction block gets added to the blockchain retrieval and is unalterable when it has been added, and the updated contents are put in the database. Now, if you are interested, you can look at this thing as well. Again, if you look at this is an example of a multimedia blockchain where a content is being transferred, and this got published in a conference on our digital signal processing, right? So it is being used for various applications. So there was one application, there was one startup which was working on, again, it's a modified form of this type of blockchain where let's say you're producing a content that we'll probably see in the future, movie or music industry. So music industry is already gearing to it now. You might see more in the other industries as well, where let's say you are going to produce a soundtrack. Now, as an artist, you connect to one of the bigger houses like HMVs or T-Series or others. You link to them, and then they can do the recording and then start selling the song anywhere, be it online or other medium. But mostly now, things are moving online. So one of the startups which started to work on using blockchain here, with the idea was that, and it actually reduces the cost and the risk for producers and others too, where they say this that the artist or the people who are doing music, so singer, musician, and all the whole team, they're all on this blockchain platform. They produce a soundtrack. So producer also doesn't give any cost or straight away payment to anyone. So they record the song. So whatever or how many times the song gets played out, the producing company gets paid, and then they will distribute this through blockchain. So there's no upfront cost as such, and it will depend on the popularity of a particular soundtrack. Similar models we might see come up for the film or other creative industries as well, where we are reducing the input or the input or the initial cost for producing house or others, and if it becomes successful, then all gets a share as discussed in their contracts. So these are some of these new technologies which are, let's say, away from when we hear about blockchain and Bitcoin, Ethereum, and also this is a different way of using it. Now, there was an article recently where they're seeing a lot of, because of this lockdown and stuff, a lot of people are working for companies or individuals abroad. So they're, let's say, based in India. They're working for them abroad, and the payments are done in form of Bitcoin or something. So they're and then that Bitcoin can be converted to INR or some other form where you can then spend it later. So that is another thing that has come up because of the again because of this COVID era. Now then there are these other regulatory issues. Will not go into the detail, but let us see. But I think in future, once we have more or more people have more confidence into Bitcoin and things, it'll come to our daily use as well. But then it poses a challenge too for so Bitcoin. All they pose challenges to different uh, currencies and things that are tied to a nation. So there's a lot of debate and things going on. Let us see where this ends up. Um, following other attractive features of blockchain, one is say decentralization. So a blockchain-based infrastructure has two nodes can engage in a transaction with each other without the need to place trust upon a central entity. So currently, a lot of the things we do, let's say I'm doing a communication call, so it goes through my base station, and then my it is so my SIM card is authenticated. And then it is routed to the next person, and then my call is connected. Right, their network might be on a different network, different parts of the world, and they get connected. So it is still very centralized. If you look at another example, let's say you are two people, sitting in a room or maybe close to each other, where there are other ways as well that you can get connected, but still, currently, your calls go through your phone to the base station, and then from base station, the other person might be in the same base station but comes back, or maybe to another service provider and comes back. Uh, but both of you are quite close to each other, so why not? They can talk to each other. That's another application area where this can come in. Similar thing we see in even in the WhatsApp messages and all. They go to the central server and then gets routed down. Right? Although you might be just sitting next to the person who you are sending or forwarding that message or information or video to. So that's actually a lot of overhead, as we see, for especially for the video, because if you're sending a video to someone, that goes through your network first, it goes up to the cloud, and then gets connected, and then again comes down to the other person networks. But if it was possible to transfer that content directly from your phone to the next person, again using WhatsApp or any other application that you are using for sharing, but that will save a lot of issues at the network level and congestions and things that occur. So there are certain, I think these things will also come into the future once they go, blockchain gets embedded in our daily lives. Immutability. Now, since all the entities made in blockchain are agreed upon by peers via decentralized consensus, the blockchain is censorship resistant because there's no central authority which is looking at it, and that's where there's always a tussle between the centralized authorities like RBI and others, and then different decentralized ones. So they I mean, this will go on, but in my opinion, this will go on for some time, and it'll eventually have to convert somewhere. There might be some hybrid forms that may appear in the future, but let's see. But it will probably happen in this decade itself. Then the blockchain is censorship free because it's more democratized, it's more decentralized. A lot of people, they have their ledger. It is known to others as well. So it's not that everything is at one central store. If anything you require, you have to contact the central store and then start the processing. So because there are multiple copies, so in a way you can say on an average, if let's say most of them are trusted nodes, they're not compromised, your information is stable. But then we can also improve this through some of the technologies that we'll cover later. The basic premise of securing the information, securing the ledger. Auditability. So all peers hold a copy of the blockchain and thus access all the time spent transaction records. So this transparency allows peers to look up and verify transaction involved independently. So it doesn't need to be going again to a central store because they all have a copy. So they can check their own things and verify transactions involving specific blockchain addresses. Now, fault tolerant, because all the blockchain peers contain identical replicas of the ledger records. So any fault or data leakages that occur in the blockchain can be identified through this decentralized consensus-based method, and data leakages can be mitigated using replicas stored in the blockchain peers. So now, if you look at this, there's another application in the reference here. So, application of blockchain in IoT, right? A comprehensive survey. So another survey article came in 2018 in IEEE Communication Survey and Tutorial. So they're also advocating the use of blockchain in Internet of Things type of applications. Um, Now let's look at what are different types of blockchains. Now, public blockchains. So public blockchains are truly decentralized, where all members can participate in publishing new blocks, accessing blockchain content. So each and everyone has the access. So public blockchains are termed permissionless, in that it allows anyone to maintain a copy of the blockchain and engage in validating new blocks. Example of public blockchain and implemented in cryptocurrency networks is Bitcoin, Ethereum, and others. Now, you can have private blockchain. You can actually have a blockchain for your own simple or single organization. In contrast to public blockchains, the private blockchains are permission, and every node joining the network is known as a member of a single organization. Now, private blockchains are suited for single enterprise solution and are utilized as a synchronized distributed database meant to keep track of data exchanges occurring between different departments or individuals. So you might, let's say, have a blockchain network within your institute as well, education institute or organization, where let's say you have different uh, things which are they're currently managed as different ledgers. So, for example, let's say your one of the bills or things gets routed from your department through to administration, through to different approving authorities, and then goes on. So, you can have this all secured within a single enterprise and implement blockchain for your own institute. And nowadays, currently we do either do paperwork or we do it's a ledger based when we do an entry in ledger. So they all can be put there, and it is democratic. So everybody has an access to this data at all the time. And when, let's say, there's a need for a transaction, then also within the organization, generally they don't transfer from one account to another. It is actually done on the papers. And when there's a dealing with the outside world, then the funds get physically moved from one account to another. But usually it is all managed within the same things on the administrative thing. Then the financial transaction happens at the very end. So some of these things can be done in a private network for your own organization, or it could be a consortium block, or blockchains or federated blockchains are similar to private blockchains, in the sense that the permission that you have to have, first of all, permission to be in that consortium. But consortium are larger, so they could have multiple organizations, and they help maintain transparency among those involved parties. So you might think of, let's say, your institute, let's say, is affiliated to a university, or let's say even the institute has different centers or different departments which are working independently, but they're all part of this one thing. So some institute, they have a medical college and this, or there might be one university where there are different institutes which are affiliated to it. So there are multiple independent organizations, but they all come under the same consortia. So they can do using blockchain network for their consortia, basically. So consortium blockchain is used as again, a portable, reliable, synchronized way of database that keeps track of data exchanges so taking place within the participating consortium members. Now, if you look at this, there's a general cryptocurrency market. So this is where actually it all, became so famous, or and many times they are actually used interchangeably, Bitcoin or blockchain, because Bitcoin is so popular that the terms got changed and used interchangeably. So the value of the global cryptocurrency market in 2019 was expected to be 702 million US dollars, and it's expected to grow at the rate of 30%, the CAGR 30%, reaching up to 5,190 million by 26. so you can see there's so much demand, so much being put there, and it is making news. Like so, we had so no, okay, this is like a one agency facts and factors, but then there are others as well. There's a conservative estimate that global cryptocurrency market size might be 754 million in 2019, but it's forecast to 1,700. So there's still a CAGR growth of 11.2%. And in general, the value of global cryptocurrency market increased by almost 900% in the in just a year. And further, so this is during the pandemic era. You can say it has increased over 900%, and further 60% of total blockchain technology value is considered in the financial market. So that's what it is. So mostly it is focused on the financial market. That's where it got famous, you can say. But then in future, we are going to see it being applied to other areas as well. So this is one figures that shows that cryptocurrency market is set to grow at a stage of 30% from this. So this is a very optimistic viewpoint. We're from 792 million US dollars in 19 to 5,190 in the year 2026. Right. So, and then there are other reports as well from Coin Market. Just put a which also says that it is going to go even more. And then people are asking how much cryptocurrency or how much crypto coins there are and in theory the answer is indefinite. And then there are questions about how much one should keep as an individual. So there's sort of interest over the years if you look at. So furthermore, there are about 100 cryptocurrencies in the market, and there has been news of some being very increasing a lot in the last few years. Some of them have disappeared too. So there are issues as well. So furthermore, almost so on the other hand, there are about 5,000 cryptocurrencies in existence and have a market capitalization less than 10 million. So there are various smaller cryptocurrencies which values less than 10 million US dollar in 2020, and they all have just come in the last few years. And then I think there was a big buzz when Jeff Bezos and they invested into they said in Tesla and all. They invested. They said working on Bitcoin, and there was a sudden jump. But there's still things which are not stable at the moment. So things are still going to go up and down quite a bit. But again, one of the I think research company says Coin Market Cap says in 2020 it was the market capitalization of all the cryptocurrencies was about 756 billion US dollars. So how many cryptocurrencies are there? There are about 7,812 cryptocurrencies in January, and then in about 324 billion is a market capitalization of all cryptocurrency. So now we'll move on to look at some of the other applications of blockchain, how they can be used. We'll look at our next generation of communication systems where they can be applied. Okay, so we'll and then we'll come back to this later on to this. So I'll just minimize this for now. Change my slide. So any questions we can take some. So I see there are 3 messages. Okay, they're about people joining in. Okay, that's fine. So I'll stop this one. I will change my slides. Okay, that's fine. Okay, so I'll first give a overview from where I left, and then we can maybe go deeper into one of them, one of these applications. Okay, share. Okay, so here we see an example of a visible light communication system. So you can forget about what it says as a pre and post disorder at the moment. So from blockchain point of view, so there could be various. So we have various devices which are talking to each other through visible light communication system. That is expected to come in the or become more common in this decade. So here they could use blockchain for transactions or changing content within the home or office type of environment between different services, and it could be routed through this itself. So there's no problem because and here you have an option to have a private network because you're doing a new visible light communication setup. So you have your own modems, your own transmitter and receivers installed in a place. So you may not need to connect to the internet, and they can share the information between each other securely. Because there's a inherent benefit of using visible light that your signals actually cannot go out of the room. So whatever information that you are sharing is okay. There's one level of security already there because it cannot go out of the opaque boundaries of a wall. Plus, it is a private network, so you can actually use it for setting your own blockchain network or private blockchain network. Then this is I think we can we'll look at it again in details, but basically just to give you an idea that there is so this setup shows us there is a macro base. So this is going to come in the 5G era more commonly because we have femto base station. We have very small base stations which will cover a very small region when they're working in millimeter wave, and they all could be connected through a macro base station at the back. So currently our macro base stations, or the base stations that we generally call, you can call them as, let's say, so we are currently in a centralized way of working. But now, if you look at what is going to happen from 5G onwards, we are going to have these small base station. You will see them in the city. So Bangalore would be a place. I think they would have already started to install things. So to around before the lockdown and all, I saw things getting installed in New Delhi in certain parts. So they're already trying to put some infrastructure in place. It's not switched on at the moment, but they are starting to put the infrastructure in place. So possibly by the next year, we'll start to see rollout of 5G in the country. So here we are working on no more non-orthogonal multiple access, but basically saying that you can have different users here connected to a femto base station and a femto base station. Now currently they connect to a macro base station and then they connect to each other, but might be a way for femto to connect to femto directly. So you might have different ones, and they share the information locally and in a decentralized way. And then here we have different users. So if I look at the case 2 on the right-hand side figure on the right-hand side, we see D2 and D3. So we have a device which is transmitting and device which is receiving. And in case of a non-orthogonal multiple access, we have at least 2 users being connected and working on the same time frequency band. So they're sharing this band, and the same could be used for security, or they want to exchange contracts or share the database through a normal network as well, because they both get the same information. Anyways, they both are receiving the same information transmitted from the femto base station, but it is the way they handle it. So the device could be interested in its own data, but it still gets information about the other one too. It may not be interested, but still it gets, because that's how the network is set up. And it then aids the one which is, let's say, one of the devices at the cell edge. It gets a lower signal. So the device which is closer to the base station aids the device which is at the edge. So what we can say, let's say because both are getting the same signals anyways, so the one device which is closer can share that information with the device which is further away, which has a lower signal to noise ratio, and the device which is further away can benefit from getting one signal directly from the base station and another one from the device which is in the middle, which is working like a relay kind of system. Now, this is something I'm just giving an overview now, but we'll go in detail in the optical network. So just wanted to give you a motivation about this. So currently, So including this course and how we have seen in the last in the pandemic era and before, so we had a huge network of submarine optical cables. Now these optical cables are for intercontinental connections for transferring our internet traffic. Then over the years, you've seen proliferation of data centers and others. And in the last few years, we have also seen optical cable coming to our homes. So we have a fiber to home connection. So that is again one area where a lot of that is actually carrying all our data at the backhaul, and we generate somewhere that goes to a metro network, then goes to these different nodes. Now these nodes, they along with the user request. So one way is within the nodes or between, let's say, intercontinental cables. They have a service level agreements. Then from one network access to another one, they have a service level agreement for different type of services, right? For example, what I mean that, let's say you have someone which has a service level agreement to provide the content within a certain millisecond, or provide this much bandwidth for, let's say, an IPL match or a football match or some other event. They need a live one full HD and so many channels of information being transmitted at a very high rate. So that's where the optical cables are going to be useful. And then they can have some other ones which are for some intermittent traffic, maybe for IoT type of setup. And they may not need a high bandwidth all the time. So there are different service level agreements that are signed between the entities, and they actually can be in a form of ledger that can be secured. We'll see them when we go deeper into the quantum networks. But this is one example. And here, in case of because we have these different SLAs or different even routing tables, which are also ledgers, they can be copied across in a blockchain technology. And let's say one of the nodes got either compromised. They start there was a security breach, but still others, they have a true copy, and the things can still be fixed quickly. Or other ways, other incident might be there was an earthquake or something else, then the link got broken from one node to another ones. So here again, blockchain technology can be used to quickly recover from it and start the operation. No, this is something we'll go in detail later as well. Not go much detail into quantum key distribution, secure optical network. So this is the same similar concept could be used for our securing the blockchain networks. We'll look at it later. Then performance list of a multi-hop wireless relay network. So this is here again, blockchain can be used where, let's say, you have a base station. So currently it's all centralized. Now to increasing the coverage, say indoor coverage, we use a device called a SUTEC, which basically does from one band to another conversion. So if you look at this figure on the top right corner, we have optical fiber connected to one of the nodes. You can think of it as a fiber to home or fiber to, let's say, one of your nodes in the campus. And then we have different relays. So these relays could be either amplify forward type of relays, which are receiving whatever they receive, they amplify and forward the signal, or decode and forward, or other modes. But let's consider only amplify and forward. And then you might have another relay. So here, this example shows that you have because within your indoor environments, you could use millimeter wave type of setup. So you can use Wi-Fi kind of setup here. And then if you have to cross or cover a larger distance, we can use a UHF or ultra high frequency, which can penetrate through the wall and can reach a larger distance. And on the other end as well, we might have another SUTEC or another device which does from UHF to millimeter wave conversion. And then finally, there is a device. So here, let's say you're going to connect them or you want to secure this network. Again, blockchain technology can be used. So these all relays because actually having the same information that is transmitted, they're all getting the same. So you can think of it, you can have a small, let's say, database, or if you have a provision to have a small memory, you can keep your ledger in these different relay nodes. Okay, so this is all about different applications. Now I'll come back to our main application. We will let's look at blockchain, and okay, let's look at a bit about 5G before we go into the optical networks. And this is what is deriving the growth as well. So I'll okay, let me share it now. Okay, let me also have now close to over 150 participants. Okay, share. Okay, let me make it full screen. Okay, you can see this new set of slides. What is 5G?
Yes, we can.
Okay, perfect. So this is what I'll say is going to be again a game changer in the future for blockchain and IoT technology. So we saw that blockchain is getting used in engineering and other application, ICT application as well. Maybe in education too, it will come too. So that's where we need higher bandwidth. So in case of 5G, we are looking at 5G as a platform for connecting virtually everyone and everything. Now, remember, for blockchain, we need the blockchain nodes to be connected with each of the other nodes at a high rate, because we want to, whenever we make an entry into one of the ledgers, we want that to be replicated quickly, or basically in theory at the same time in all the other nodes as well. So they need not go out of sync. So that's where the applications of different applications that we are going to see in the 5G will come in. So we have a 5G which is designed to be flexible and scalable in mind, in order to provide this unifying connectivity platform for future innovation. So we are looking at things like enhanced broadband, mobile broadband, mission critical control, massive IoT. So they all have different. So you can look at they're serving a different industry vertical, and they need to be designed, or different parameters to be chosen to be able to serve a particular industry need. Now, some of the KPIs will be 10 times more throughput, low latency. This is very important, for blockchain plus other applications too, where things needs to be updated or action needs to be taken very quickly. For example, applications like our autonomous vehicle things. A similar thing is for blockchain as well, because you would not like to wait long for ledgers to be updated across. Right now. And they, once, if let's say the update is later, then they go out of sync. Right? So you need that to be there. Then more number of density. There are 10 times more connection density, enabling more efficient signaling for IoT. Then 3 times more spectrum efficiency, large data rates. Then higher 100 times more traffic capacity is expected, because there'll be more number of devices using the network, and then network efficiency needs to be improved for the energy consumption as well. So there are some of the KPIs for 5G. Now, if you look at the figure on the top right, again, we look at different industry verticals. One is the enhanced broadband. So here, okay, the focus is to increase the throughput, to have more immersive technologies. That is fine. Then there is a mission critical services, where we're looking at autonomous drones, or controlling a drone, where again latency is a big issue. Then for industrial IoT as well for machine to machine for industrial applications. Then autonomous vehicle, we are looking at health monitoring, where mental latency is a concern. Similar thing concerns are there in the blockchain update as well, that we need to have a low latency. Then the other one is a massive connectivity. So here we're seeing, let's say, even in your blockchain setup, where you have a need to have large number of devices connected or large number of blockchain nodes, but then only some of them will be transmitting are allowed to, let's say, update the ledger, and the ledger update is also not so frequently, like like in a stock market, things are changing every few seconds, but that's not the case here. Let's say it is going to change once in an hour, once in a day or something. So then your requirement could be like you can go for the flavor of 5G as a massive IoT and have this things running on, have blockchain and things running on a wireless network, right? And a lot of things we have seen over the years, they have moved on the wireless network. Now we're getting into so many apps, and you can do mining on your mobile phone as well. So you may not be connected in one place. So this will be deriving, I'll say, the next level of driving the next level of applications for blockchain. Right, and one of the flavors of 5G can be used there. So I'll skip this one. Um, so if you look at here again, there are different types of applications. So augmented reality, machine, self-driven cars, voice, and so they all have different requirements. Here also we see massive IoT, mission critical, enhanced partner. So this was this is a change that we'll see from the previous generations of. I'm not going to detail of these technologies, but basically this is a change that we are seeing from the previous generation of mobile communication, 1G, 2G, 3G, 4G. So there, let's say the focus was only on the voice. 2G was again voice, reaching billions of people. Then slowly we're moving towards data, and then mobile broadband started to emerge around 4G, and now 5G. Everything is on IP, and everything is on data. But here we look at this figure. There is different industry verticals that it can be tailored to. So I said, 5G provides a platform where different services or different type of applications can be run on. And okay, technology wise, it didn't happen, let's say, overnight. There has been work since 1985. And then these are some of the technologies like OFDM, mobile millimeter wave, unlicensed spectrum, and others. They all have been tried and tested before in different standards, and they all come together in the making a foundation of a 5G. And these are some of the data rates that we're looking at. So from Mbps to 10 Mbps, 100 Mbps, Gbps to multi Gbps, and we have these technology-wise, so multi-edge LDPC. So edge computing is another area that is again going to be. We'll start to see the outcome or working of it from 5G onwards, because we have these small cells which are able to now do some processing. So they have a compute, they have some memory, so they can do some processing at the small base station itself. So it is again a more distributed rather than more centralized type of architecture. Although our radio heads and RAN, they're going to be moved more into the cloud, but the small base stations could be used for doing mobile edge computing applications. One of them is caching. They could also be again used for blockchain processing as well. So we are expecting this revolution for 5G start around 2020, but because of pandemic got slightly delayed. Now here we'll see, I think in the next slide we'll see how it is different than the previous ones. Transition. Okay, this is okay on the technology side. I'll skip this one, but this is what we see here in 5G: multiple connections simultaneously. This is important. Again, for any type of distributed computing, you need to be connected to different devices, and in fact, they might be using different type of radio technologies in 5G, which was not there even till 4G. We are actually using one the same radio technology. So there's one radio connection at a time, and there's only actually one radio technology that we're using. Then single network for broadband video and machine type traffic, which is currently existing. But in future, we are looking at network slicing for different needs. Then we're looking at first step into the cloud. And here in 5G, we're looking at cloud train and other applications where a lot of these signal processing and machine learning will go into the cloud. And some of them actually could be done in the small base station too, and they can make independent decisions. So it is getting towards the distributed learning scenario. So here, in case of blockchain, also you need to connect to different type of different nodes, different blockchain nodes. They might be through different radio sets as well, but which is not possible currently in 4G on the physical layer. Yeah, and once your information is in the cloud, then yes, you are connected, but physically you are not not connected there. So this is also moving towards a distributed type of architecture. And okay, this figure shows, but what will be of interest would be the last two. So sub 6 gigahertz, you see, and the centimeter millimeter wave. Actually, there are three different ways. Might have another slide. Yeah, this slide. So if you look at this left line slide, new spectrum. Well, in till let's say in the first in the 1G, there's not much mobile phones there, but from 2G, 3G, and 4G, they all use the same um, bands for mobile communication. But here, in case of 5G, we're looking at three different bands, because they're again designed for three different use cases. So we have a below 6 gigahertz, centimeter wave, and a millimeter wave. Because again they are designed for different applications. So we look at this here. I think there's one slide here. Okay, I'll just look at one slide here first, and then we'll move on to the other one. So here, where I'll show you the difference in different radio access, their application for which they're designed. Now, this is a map which is showing 5G rollout. Okay, things got a bit delayed because of the pandemic, but this is how it looks like. It is going on. We are having the Western Europe, even Eastern Europe, getting 5G from the start. Then North America, China, Japan, Korea, and interestingly, the Middle East as well is on the top of the technology now. 5G in Australia and other places, and here also in India, we're expecting in a couple of years. But if you go back for 2G or 3G and even 4G, there was a longer delay, but slowly it is getting removed from or getting reduced from when the technology is launched in the world. The standard is formalized. So when it is launched, let's say the products are launched in the other parts of the world, they get quickly installed in India too. So, for example, like in 2G and all, we're looking at delays of 10 years. Now, slowly it became for 3G. It became 8 years or so. Then 4G it was around 6 years. Now 5G we're expecting, let's say 2 to 3 years. If 2020 around that was the time when there was official launches happening. But I think more will happen again 2020 because again things got delayed a little bit. But we are maybe 2 to 3 years behind when things got installed across the world. So here, let's look at this is the figure that I wanted to. Yeah, this I wanted to look at. So here we look at three different. Says we have a low band, we are 670 megahertz. The intent here is to have a deep coverage, deep indoor coverage of 1 kilometer or more than 1 kilometer, data rates of 100 Mbps, and then different technologies. But they're basically designed for larger area coverage. Then there's a mid band where you can expect a higher data rate of 1 GPS, but then the range, the region becomes smaller. Then the millimeter wave, we are having where this is we're looking at 27, 28, 39 gigahertz. Things like hotspot are there, but then the data rates are huge. 10 Gbps data rate and the bandwidth of about 1 gigahertz, so which is huge. And as I said, yeah, they're done for various applications. So if you look at extreme local capacity, then you go for 5G millimeter wave. If you want to have larger coverage, lower data rate, you go to um, 5G 3500 millimeter wave, or you go to the very top, so 5G 700 for a IoT or critical communication with full coverage. So here we can have a 10 megahertz band, but you're covering a very large distance. In an IoT setup, or in a network where you have nodes or sensors being deployed in a larger area like a campus type area or in a city type area for smart cities, that's where this can come in. So smart cities as well, they can use a blockchain once you have this integrated system. So for example, you're looking at this integrated transport systems in some getting deployed, so where you can do uh, you're using a bus and a metro and things together, and you use only one card which will do the detection. So there also again we have IoT sensors, that is fine, but then in the back end it is the blockchain technology can be used here. Now, right mix of 5G and capacity, again the similar thing, but yeah, basically saying that if you want to do a larger coverage, you go for LTE 700 or the 5G 700, then or you can go for 5G 3500 if you want, let's say, in between, and then if you want a very high data rate, you go from. So these three things were not there for in the 4G era, but now here in the 5G and beyond, we'll see actually even more. So designed for different industry verticals. So let's skip this one, and this one figure shows how they might they will be co-working. So you have a macro base station, a small base station. So you can have multiple of these small base stations which could be communicating with each other, so in a distributed fashion. And then you have so they are working in above 6 gigahertz. They cover a smaller radius, and then your handsets will be multi-mode devices, so having 5G, 4G, and maybe 3G plus Wi-Fi, um, so that when you get a seamless connectivity. So if you're closer to, let's say, macro base station, it switches to 4G, and when you're, let's say, moving towards your left hand side with this handset, you get connected to the 5G network. So I'll not go into the technology details here, but basically saying that, I mean, this is this is something I can. So Noma I was telling you about. So this is again one of the things that comes naturally with the blockchain, because so currently we have this orthogonal blocks here. If you look at this figure, we have FDM plus TDM. So this is how it works at the moment. So all of us are getting that orthogonal block of a resource allocated to us, a bandwidth and a time, but all of us may not be using the whole slot. We might be using only for voice, so we may not need 2-3 megahertz of bandwidth. But if I'm doing video, then I downloading, then I need it. But then it's a fixed allocation. So if I'm not using it, it's a waste. If I want slightly more, then I'm also in trouble, because it cannot go beyond. Then there'll be compression and things will be happening. Now, in case of Noma, if we look at either power domain or other type of flavors of Noma, basically the idea is that we break this orthogonality and use the same time and frequency for serving multiple users, and they all get the same information to them as well. So currently, if I have, let's say, two users, so user one and user two, they are going on an orthogonal block. They are not sending the same information to both the devices. But here, in case of Noma, the same information is sent to both the devices. So that can actually be exploited, I believe, for the successful blockchain implementation in the future. And also with Noma, we can increase. Basically, the idea was to increase the number of users being used, but then because the information is being replicated, it can be used for a blockchain as well. So that's something that can be explored in the futures. And IoT, such as one of the applications, will not go again in detail, but just wanted to give an overview. I'll skip this one then. Okay, so now let's go back to. So let's go back to the networking aspect. So let's go back to this now. So where we are applying blockchain. So I'll just give a overview. If you're not from an optical, I have not worked on optical networks before. I'll just show a few slides on this when we or then we will with some basics, and then we'll go into the actual implementation. So here, let me attach my screen. Yeah. Okay. Okay. And how am I doing with the time?
Yes, sir. We have around 10 minutes.
Okay. Okay. So I'll quickly go over this then. Okay. Right. Let me quickly. So this optical network we already seen. There's some okay, that is fine. We'll not go into what is FDM and this. What I'll go over is here. Let's go here. Now we discussed about optical network because they form the backbone of our network. So now let's look at this slide here, which is again showing that in the future, the optical networks are moving from WDM to elastic optical network, which is a similar type of technology like OFDM, where again different type of different bands can be allocated to different users. So this is again moving from this fixed type of allocation, basically. Right. So now optical communication networks are also vulnerable to various types of security attacks. So now so initially that was not thought of that it could be done because optical fibers, were to have an optical network, you need to dig the road or the infrastructure, and then put the cable in, and then it goes through a fixed. You see, within the sheet, it goes, but then later on, the technology has been developed where eavesdropping can happen. It could be data interception and jamming attacks. And we hear about these things in the news as well, that things happened in some part of the world where the whole network was brought down. Now, such attacks can have a huge amount of data and revenue loss. And also you can think of it as in case of a IP network or in case of a submarine cable, they are going. So IP network, okay, it's going across the world, but then through the submarine cable, it might be going through, a region where let's say there is animosity between the neighboring nations, and but because you have to connect to the full, the through internet, and it has to pass through a neighboring country, so you might like to secure it more. Um, and now we are looking at more breaches, as you said, in the optical fiber communications to security breaches. So where quantum key distribution has emerged as a promising solution to protect these. And remember, in case of a blockchain, we need to secure these hashes so they cannot be quickly decoded in the real time. So now let's look at what is quantum. So quantum is a smallest information discrete quantity of any physical property such as light or energy. The system can process according to quantum theory. A photon is the smallest unit of light. So that is why we're seeing quantum mostly in the optical domain. And then there's a quantum information science, which is in physics, maths, and engineering. But our focus is on quantum communication, but there are quantum sensing technology, computing as well. So here, if you look at quantum communication, is the process of securing information from transmission to the reception, and quantum cryptography. So this is an art and science of utilizing the fundamental principle of quantum mechanics for performing the cryptographic task, i.e., protecting confidential information against security breaches. So this is important for our blockchain movement. So here our focus has been on looking at quantum cryptography in QKD, quantum key distribution. Now, quantum key distribution, so QKD is a secret key over an insecure channel, and based on two fundamental laws of quantum physics, namely Heisenberg uncertainty principle and quantum no cloning. So let's briefly just look at, if you are interested, you can look at these references in detail. So Heisenberg uncertainty principle, it is impossible to make simultaneous measurement on physical properties of a particle. For example, position and moment. So there'll be some change basically in the this because you're looking at the particle from two different points. Quantum no cloning. So quantum no cloning theorem states that it is impossible to create an identical copy of arbitrary unknown quantum state. So this is something that can help in the securing of an optical network. So let's look at an example. How, let's say, two parties are going to interact. So QKD enables two parties, Alice and Bob, to produce a shared random key known only to them. A shared random key can then be used to encrypt and decrypt messages using quantum channel and an authenticated classical channel. So here the idea is we really don't want to put a separate optical fiber for a quantum network. And when the quantum computers, they start to come to mainstream, then they're expected to break the encryption algorithms that we're using, AES and others are using at the moment, in real time. And that's where the problem will lie for blockchain and others as well. If it can be easily eavesdropped. Now, a shared random key can then be, so that's why we are moving towards quantum key QKD secured networks. Now, secured and QKD enables two parties to work on this secure network, and a shared random key can then be used to encrypt and decrypt messages using quantum channel and authentic. And we are basically going to use the same classical optical channel. We'll not know how it is done, but basically you need to have a system which is secured by a QKD protocol. And then there are different protocols. If you're interested, you can look at BB84, one of the most popular protocols. And as in the previous case as well, you see it was proposed in 1984, but it is making inroads now, and we are seeing the quantum IoT devices, routers being available. We'll not go into the details again, but just wanted to give you a short overview. And now we'll move on to the how this can be used for our blockchain networks. So this will be the last set of. So I'll again come back to the slides we started with. Yeah, I'm just opening this one up. Okay, so let me share this now. Okay, so I'm back into the same slide deck. Okay, so the motivation for having a quantum secured blockchain. So this is something that we have been working, recently started working, and very early work. But this is one of our novelties that has come from our group. We're looking at blockchain relies basically on two one-way computational technologies like crypto hash and digital signatures. Most blockchain platforms rely on elliptical curve public key cryptography or the large integer factorization problem RSA to generate these signatures. Now, the security of these algorithms is based on the assumption of computational complexity of certain mathematical problems. Now, the evolution of quantum computers will easily break the security of such methods, thereby making blockchain technology insecure. Also, it is predicted that about 10% of global GDP will be stored on blockchain or blockchain-related technologies by in the next 2 to 3 years. Right. So so 2025 we will get into this era. So it is highly with high time that we think about looking at ways of securing the blockchain network. So the security of blockchain can be enhanced by using post-quantum digital signatures for signing. This is one solution given here in one of the papers in Article Access. But then there are other techniques as well that we look at. So however, the post-quantum digital signature schemes are not helpful against attacks that utilize quantum computers because they can compute and break the keys in the faster than in real time. Therefore, there has been a renewed interest in research on enhancing security of blockchains by using quantum technology and quantum key distribution. This technology is known as quantum secured blockchain on the very first things here. So quantum key distributed keys over an insecure channel based on fundamental laws of so this we have covered already. QKD also we have seen. We'll not go in detail how there. So that okay, there are two design schemes. We'll not go in detail. If you're interested in quantum, you can have a look at it or get in touch with us. We can have a discussion later on. Okay, so basically, now let's look at quantum secure blockchain. It uses the components of traditional blockchain, however, utilizes quantum technology to secure network against security breach. So recently, a quantum secure blockchain platform has been developed and experimentally demonstrated, which uses QKD for authentication of original uh, Bernstein fault tolerance consensus protocol for validation. So this was done in one of this references here in 2018, but still very early because having a quantum network it takes time and setup. So quantum optical networks is essentially because of emergence of various technology, and we're looking at them being used in defense, financial services, and others. Now, different security attacks such as wormhole attacks and cyber attack, they disable and create fake network resources and can have huge financial loss and privacy loss and a large amount of service disruption that we see in the news quite a bit happening in various parts of the world. Um, so blockchain is can be made more secure by using quantum computers, and now because we are having optical network, we can try to combine all this together to propose a secure network using QKD with blockchain and running on a optical network. So the ever-growing. So basically, what we want to say is that for ever-growing needs of a fraction of our daily activities, including email, banking, now it is all through public channels going on optical fibers. As security issues are gaining more importance, a lot of information is being transmitted, and blockchain has been adopted to secure confidential information against various security attacks. And in contrast, QKD is a promising technology which can fix because the blockchain technology relies on encryption and with the emergence or coming of quantum computers, this security may be breached quickly and also in the worst case in real time. And in contrast, QKD is a promising technology to establish a secure connection between end users by generating a shared random secret key. And therefore, in order to protect optical networks against malicious attacks, QKD combined with blockchain running on an optical network is one of the solutions that can be explored in the future. So this is where I'll like to end. There are some of these references you can have a look at. So I'll pause here for a while. Okay, thank you. So if you wish to get in touch with us later regarding this or any other areas that excite you that we have covered, that we're working in our research, so feel free to get in touch with us. So thank you. Thank you very much.
Yes, sir. Yes, sir. Yes, sir.
Dr. Vimal, would you like to, 1 minute, Karthik, would you like to talk to the participants, because most of them are from academia, about the internship programs at Indore for students as well as research internship?
Okay, sure. Thank you. Thank you very much. I'll just give a short overview. So here at IIT Indore, we started online internship and online summer internship, and you can say research internship. So the summer internships or what we call most undergraduate internships, they are designed for 1 month, 2 months, 3 months type of things, again depending upon the areas that they want to work in and the duration that the student has. So in fact, this year we had I think now throughout the institute around 1,000 students who are currently doing their internship. Some has finished, some are going on. So in July, August, some even go for September. So these are designed so you can encourage your students to visit our website, and they simply need to send an email, and then the instructions will be shared with them how they can join the internship program. So in our group as well, we're actually currently running one on AI, ML, and DL. Our focuses has primarily been on so we're giving, it's like a tutorial plus a hands-on thing. So we started from the very basics of machine learning, what is machine learning, and now we've reached somewhere close to CNN at the moment. So every week we meet for an hour or so, and then we give some problem statement that students can work on in their own time and get back to us with their reports. So this is for a shorter, engagement. Then there is another provision for faculty members and even the postgrad students, and also undergrad students. Let's say who are interested to pursue their career in research, so they can join for research internship. So they're a bit more intense, and they last anywhere from 3 months to 6 months ideally, and as all of you have been involved in in research, so it takes a while for any thing to product to come out, and then our review process also takes a lot of time. So between again the faculty member and the things they can sign in, so through because it's done through IIT Indore, all the certification and things are all handled by IIT Indore administration itself. So in a way, we can connect the undergraduates, postgraduates, or even faculty members in other institutes. They can join us for increasing the research outcome if they're interested in certain areas. So things are there on IIT Indore website. You can visit the website, or if you have any queries regarding the same, you can drop me an email. So currently we have actually around 70 odd students have signed up for various different durations. So some have joined for a month, some have joined for 2 months, some have joined for 3 months, and some have actually extended their stay with us because they want to do something more in the same area. They're doing some problem, they want to have a difficult problem or want to explore more, and some of them would be interested to pursue it for towards working, let's say, towards a publication or something, towards more of a research kind of objective. Then some are interested like learning more. Then, but here in research, you'll expect something tangible to come out. So it takes a bit of a time, and but that requires more intense interaction between the the faculty members and the research scholar. But for internship, it's mostly between the our research scholars and the BTech students. And so this, I think, again, is very good initiative. And again, we are doing online in our area. Anyways, we don't need much experimental stuff. We need high power GPUs or CPUs or computers in our mind to brain to do things. So I think they can be done from anywhere. So now, as I'm telling, I mean, currently for the internship that I'm running, I've got students from very north of the country to very south, and also from northeast. A lot of students have actually joined in Assam and so again, you see, if it was physical, then difficult to arrange logistics, so that takes away all the logistics issue. We communicate over online. And help them in their learning, and also they can do a minor project with us in the internships. For research internship, yeah, that will be more intensive, and that needs to I think properly planned for 6 months, at least 6 months, to get a good tangible outcome. And be it a student, be it a postgraduate, or be it a PhD. I think the maximum duration that is mentioned is 1 year. Because for PG research, PG level research, or PhD level research, it needs time and effort. Right. Thank you very much, Mazli. Actually, I wanted to talk about this at the start and I forgot. So thanks for reminding me.
Yeah, because there are quite a few people, almost 148 from across the country, Dr. Vimal. So it would be good for them to know, because within my college itself, people didn't know about it. Yeah. So it would be nice. So that's why I thought, let me remind you. Yeah.
No, that's great. That's actually yesterday already I got a couple of emails. So some of the UG students, because again now with the pandemic, the schedules have skewed a bit in different places. So some they were having their exams, they finished. Now they want to do internships. Some they were doing internship. Now they have exams. So the window has moved for internship in various parts of the country. So in fact, like yesterday, there were a couple of requests from students they want to do for a month. So that is fine. So even if you have, let's say, students now, they can drop an email and we can try to accommodate them at the moment too for a month or so. That's also fine. Thank you. Thank you very much, Madhuri.
Any questions from the participants?
Yes, I have one. Thank you, Dr. Vimal, for such a wonderful session. I have one query that is basically related to, I guess it's in slide 13 or 14. There it was mentioned that block header is hashed twice. So is there only means the purpose is for better security? In 13 slide, I guess.
13 is more, maybe one before transaction.
Yes, it's mentioned here.
Yeah, I'll say that, because I mean, see, the whole blockchain is basically for the security purpose. Basically, we need to we do this, and even if you look at, I mean, we have been doing something similar. So also, again, it's not a new thing. We have been doing this in the past as well. So if you look at let us say our how we are doing currently for handling different medias as well. So even in our media, like for our even it is even from the CD, when we're using compact disc as well. So the media used to be transferred on this one, like film and everything. So there, because certain information needs higher say compression or security, we use either different type of algorithms or more secure algorithm, and other information may not. So for instance, whenever, let's say, compression is done on a content, we have certain headers, so which, if someone can, let's say, crack those headers, they are able to decode the message. So we may in fact not even encrypt the message part, but that header has got a lot of sensitive information about that, or how we can decode, or let's say in the case of media, how do we play it back, who is the author, and other things. So you can think of something like a DRM and those technologies that were there for content management. Similarly, we have here as well that we want to secure this information much more than the content itself, because the idea is, if you are unable to let's say secure this, then content you will not be able to decipher. And other thing is, content is actually very large, so you want to actually secure your headers more than the than the content, because content is very large. So if you want to run it twice or thrice or something, it will like it may use a lot of space. It may not be very useful because of the real time constraint. Ideally, yes, you might like to do it, but in real time, you might just do it once.
Dr. Simal, there are a few questions in the chat too. Could you please check that if you have not already answered?
Sir, hello, sir.
Yes.
Sir, I am Sumar Majumdar. I have one question, sir. Actually, sir, how the transaction, or can you please define how the transaction is used, and how it is working for the blockchain to maintain the security, or in which form the transaction is used?
Okay, no, so transaction is something that we want to secure. So that goes into our ledger, and so I believe. I mean, I think for this question, once you start, getting into details of blockchain in the next sessions, and once you start implementing a blockchain network, you can then relate what these transactions and how they are added into a ledger. So I think that if you just hold on for the next few sessions, you will be able to.
My question is the transaction is performed in any binary form or like that one? I want to know the structure of the transaction only, sir.
As Dr. Vimal said, that there is a complete hands-on session on consensus mechanism, message exchange, and other things, sir. So kindly hold on, please, because it's not a simple answer. It needs you need to understand some stuff before knowing that. Okay.
Okay, sir.
Yeah, it's not. You cannot say it is binary. You cannot say it is encrypted. It is a combination of a lot of things. So sorry to interrupt, Dr. Bhatia, but I thought I should.
No, thank you. Yeah, thank you.
At the cost of time, no, like
we should
ensure that things move on. Okay.
Yes. I think it's a very exciting area, so people are really excited. So you will see them in detail when you start to do implementation, as Maithili rightly mentioned.
Okay, sir. Thank you.
Good morning, sir.
Yeah, good morning. Yeah, okay. There was one query on the chat box. So previous one I have covered. I think the last one was about so my mail ID is on the last slide. But if you just do Google search, you will see the the email ID. Yeah, so there is a provision for faculty. Sorry, just a minute, please. There was some query, so I'll just go over what was on the chat message. So there's a possibility for faculty internship as well. Yes, there is. It is there. And I think before that I have already covered. Yeah, there's some WhatsApp feedback. That's okay. I'll move down to Preet has already done. Yeah, so email ID and stuff you can just do Google and also find out. Also, it was in the last slide. So it's basically vbhatia@iiti.ac.in. So the initial from the first name and followed surname, just one word, @iiti.in, iiti.ac.in, and then. Yeah, so the survey article, yes, okay. Well, I think even if you do a Google search, or let me see, I think it was one of the slides. So till I answer the other question, you might get it. But yeah, it is something very interesting. Yeah, so one option could be you can drop me a mail. I'll find out I had a link somewhere in emails, but it is on the portal as well. Just you can drop me a mail. I'll forward you the link. So there was this query from Purnima. Yes, and there was someone who was talking and had some queries. So please unmute and continue.
So good morning, sir.
Yeah, good morning.
This is Lakshmikant, sir, from DBIT, Bangalore.
Yeah, good morning. Yeah.
Sir, my question is it possible to provide security to big data?
You see, that is
by using blockchain, sir.
It is basically the way it is designed is for small information, and the thing that you want to secure. So this because there's a lot of traffic that is generated, and you may not be requiring to secure everything. For instance, let us say we are having this class here, or this session here. So I may not have a need to, really secure it to that level. So I'll say it is. In theory, if you want, you can apply, but then, but there's, considering, putting millions of or billions of records, it will be very difficult for a real implementation. So rather, we'll focus on smaller. So like for example, in case of financial sector, there's smaller entries, which let's say somebody is debiting somebody. So like your bank statements and also the small ledgers they come. So that is okay. But having a big data, let's say if I want to have a full movie or something, so blockchain, it is probably an overkill for the whole thing to be there. Okay, I'll go to the reference slide. Yeah, so I think it will be more of a use case basis. So I'll say not apply to all the problems that are there. So only places where you need security or distributed ledger or transparency. So those are the places where you will apply. But not in every application, I'll say, not in every. So although if you want, you can apply, but then it might be an overkill for that small application. Even like handling big data, again, it will be a lot of data to run through this. Encryption is difficult. It takes a lot of compute. So SDN is a centralized network. How can blockchain solve the... Yeah, so this is something we have been exploring as well, but our focus has been coming from the optical network aspect, because again, let's say one of the nodes got down or something, or there was some connection failure there. So in that case, you could either route the information through a different channel. So here, we say in blockchain, let's say one of the nodes got issues, it got compromised, or there was a network failure. Then still, because the copy of the ledger is with all the other nodes in the network, then you can still get high level of security. But I believe there will be some theoretical studies done somewhere, like where let us say X percentage of nodes are showing some information, and then if it goes beyond that, then it is thought of as true. So let's say in a consensus based system, if it passes through some threshold, then everybody is then thinking in the same, or all their ledgers get updated with that incorrect information. So there might be some studies, and maybe you will see them in the later courses, where when you come to implement it really to have a blockchain. So blockchain, let's say if it's one-to-one user, then I'll not use it, right? But it will be, let's say you have more number of users, then you can apply it again in certain cases. Again, I'll say not in all the cases. You'll apply it in certain applications. So I've changed my slide to reference number 2, so you can have a look at that. Yeah, so these things, I think we'll cover them. We will cover them in the next. So this was a talk to give an overview of how these things are getting connected. So we have let's say quantum, we have blockchain, we have 5G, so, IoT. So all how they're all connected to KD, how they're all connected.
Okay, due to paucity of time, any further questions, kindly email Dr. Bhatia. Karthik, can you please take over?
Yes, ma'am. Yes, ma'am. Yes. So it was a wonderful session. On behalf of MSRIT Department of Information Science and Engineering, I would like to thank Dr. Vimal Bhatia for his wonderful and informative presentation and providing the insights on performance analysis for 5G communication, and then solution in terms of industries and then the defense. So this distributed ledger technology is a very new concept in terms of blockchain, where the major process works on that ledger technology, how the data is being completely forwarded. Then the process of blockchain, the features in terms of decentralization, and the insights on general cryptocurrencies. What Dr. Bhatia has been given is really an informative one. And then the 5G global rollout. Exactly, most of the people will not be knowing about 2020 to 2021, how the process of blockchain has been completely involved in these years from past 4 to 5 years. And then quantum secured blockchain for optical networks, a very good insight on that. Then quantum communication process. So overall, it is a very good session and very informative. I think for the participant, you got much a brief process how exactly the blockchain process will be communicated. In the further sessions, we are going to check in depth on this one. On this note, I would like to thank Dr. Bhatia for the wonderful session, sir, keynote. Thank you so much, sir, with having with us and spending your valuable time with us. Thank you so much, sir.
So thank you very much, Karthik, and thank you very much, Maithili and the team.